Namaste and welcome to Unnati Education videos. So we are today discussing about one of the second PUC topics or plus 2 topics. That is, we are in the first chapter, electric charges and fields. Under that, we have covered 20 parts. 20 videos we have seen, and today we will see the 21st session in electric charges and fields. So far we have seen the properties of electric field lines. We have understood what is electric field lines and what are the properties of electric field lines. Those much we have finished so far. Just refer the last video and understand and remember about properties of electric field lines. So today what we do is we'll try to represent or draw electric field lines for simple cases. That is, first of all, let me just consider a positive charge. A positive charge. You know the property of electric field lines for a single positive charge. How to draw electric field lines for a positive charge. Just imagine this is a positive charge and I want to draw electric field lines for this particular positive charge, unit positive charge. So how to represent that? From the properties of electric field lines, you know, for a positive charge, electric field lines are towards out. They are going out like this, right? So direction of electric field lines is this, isn't it? Right? From the properties of electric field lines, you can draw. This is the way in which you can draw the electric field lines. Electric field lines for a unit single positive charge. And for a negative charge, suppose you have a negative charge and it is a single charge. No need to be unit. All these charges may be having any value, but the condition is Q. The charge should be greater than 0. It is not 0. Should be having some value. And from the properties of electric field lines, again you remember, for a negative charge, field lines are towards it, inward, right? They are inward. So these lines that I am drawing now, representing what you call the electric field lines of a single negative charge. Okay, this is for positive charge and this is for negative charge, right? Here also Q is greater than 0. This is the condition. Okay, here you can see the properties. These lines follow the actual properties of electric field lines. See here, you can understand the strength of electric field. See here, this is a charge, right? Charge is at the center, and the strength of electric field you can understand from these lines. See, if you see at the nearest point to the charge, number of lines per unit area will be more there. Number of lines per unit area will be more. These lines are nearer here. As you go far away or as you go far from the central charge, what you can see here is the distance between the lines increases. That means they are rarer there. That means the strength of electric field decreases as you move away from the charge. Here also, right? So that is what you can understand from this. And now suppose if you have a positive charge and a negative charge, equal and opposite charges. Okay, a positive charge, this is positive charge, and this is negative charge. Suppose this is the case, how to draw electric field lines? How to draw electric field lines? Usually we know, generally we can say if they are equal and opposite, or they are opposite charges, they will be attracted each other. They will be attracting each other, right? So how to represent that attraction or prove that attraction using this method, that is by drawing the electric field lines, how you can prove that? That is the question now, right? So that is, for a positive charge, electric field lines are, you can see here, outside, going outside, right? From it, lines are moving away, moving outward direction. For a negative charge, it is inward, towards it. Okay, so at this point, if I draw along this line, if I draw the directions, this is the direction for this, and this is the direction for this. Correct? So this line itself shows that they are attracting each other. They are attracting each other. Suppose if you have the same thing here, here, and here, here, like this you can continue. Like this you can continue. Sorry. Yes, like this you can continue. Yes. It goes on. Right. So what is the direction in all these lines? What is the direction? Yes, towards outside and inward, outward, inward. Right? Yes. And here also, this is outward, this is inward, and this one, outward, outward, outward. Here, inward, inward, inward. Right. Yes. This is how you represent the electric field lines, or you draw electric field lines for what? Two opposite charges. Here, we assume they are equal and opposite charges. And suppose another case, if you have two positive charges like this, two positive charges. Suppose you have two positive charges, how to draw electric field lines for those? Just remember what will be happening here. What will be happening here from the condition, two charges, they are equal. They will be repelling each other. They will be repelling each other, not attracting each other. They will be repelling each other. So, for a positive charge, this is the condition. Outward. Lines will be outward. So here, lines will be outward means how to draw them. Okay, I'll draw the lines first, then we'll see about directions. Okay, so here, how to draw the directions now? I have the lines now. How to draw the direction? Towards, away, right? Outward direction, outward direction. So these are the directions of these lines. Electric field's direction it is, right? So here, should I draw the line? No, right, because they are repelling each other. So this one shows the repulsion between the equal charges, similar charges, right? So this is how we draw electric field lines for this. Suppose negative charges you have, and negative charges, two negative charges, equal charges, right? So here also what should happen? They should, and they will repel each other. Repel each other. Okay, enough I think. For understanding it is enough. So towards the charge, direction is towards the charge, as they are negative charges. Direction is towards the charge, right? Yes, this is for negative and negative charges. So just remember these things. For a positive charge, for a negative charge, for opposite charges, equal and opposite charges, that is plus and minus, and positive charges, equal charges, negative charges, right? This is how we draw the electric field lines for different charges. Simplest cases we have seen. This is the thing that is included in your syllabus. Okay, shall I rub it? Yes. Remember these things. Remember these things. It will be handy for you. Even in competitive examinations, if you know these basic things, you can answer many questions. You can apply these basic things and you can analyze the bigger, complex things about drawing the electric field lines for different cases of different charges. Next topic is electric flux. Electric flux. Don't worry about the meaning of it now. We'll understand it. Step by step I'll say what we have to understand. Just remember electric flux, the word is represented, this term is represented by delta phi. Delta phi. This is what you call as electric flux, delta phi. Okay, now just imagine this is surface. This is a surface of something. Surface area. Just remember, just imagine this is the surface area of something. Surface area of something. And what I'll do is, I'll choose a small unit area in that. Small unit area in this. Okay, this area. This is my chosen area. What I call this area as area element now. Area element. I need this term here. That is why I am saying this is area element. I will represent that area element as delta S. So what is delta S? Delta S is area, small area, and delta S I will call this as area element. Area element. And while calling this as area element, what I will do is I will represent this as a vector. I will represent this as a vector. Delta S is small area, and I need area element here. So when I am calling this as area element, it becomes a vector. What is the meaning of that? The meaning of that is area element is a vector, right? Area element is a vector means it has a direction. Vector has a direction. So how area gets a direction? Just remember, area element is having a direction that is normal to the surface area. So this is n cap is unit vector which is normal or perpendicular to this area delta S. So delta S vector area element is nothing but delta S n cap, where n cap is the unit vector normal to the surface area, right? So this is area element. Remember that. Okay, we are not into the electric flux now, just defined or understood what is area element. So I have chosen this area element, and just imagine in this place, E is the electric field. E is the electric field. Okay, electric field, not electric flux. Flux is represented by delta phi. Right. Now, what we do is, we'll try to define electric flux. Okay, we are into the topic now. So, you understood what is delta S. You understood what is E. I said what is E here. Now, what is delta phi, electric flux? You know what is electric field lines, right? Electric field lines. So, what I am defining now is electric flux. Electric flux. So, electric flux by electric field E. So, I am going to define electric flux by electric field E. So, electric flux due to electric field E is the number of electric field lines, cutting the area element delta S normally. Okay, don't be serious. Take it as funny. You can understand it. Just taking it as seriously and reading it again and again and try to understand, try to by heart it. By hearting you cannot understand. Just remember word by word and relate them. Then you can understand. That is what I am doing now. Area element, electric field. Now, using the concept that we know, that is electric field lines, we are into electric flux. So the definition of electric flux is electric field flux due to electric field E is the number of electric field lines cutting the area element delta S normally. Okay. So this is the definition of electric flux. Nothing. This is the area element we have chosen, right? So through this area element, how many electric field lines are coming out normally, perpendicular to this surface, normally? That number itself, that number of electric field lines itself is nothing but electric flux. Simple, very simple, right? So just remember the definition of it. You understood it, I hope. Slowly I have explained it. So obviously you should get it. This is the definition. And equation wise, electric flux delta phi equal to E dot delta S. E dot delta S. That is E, you can write it as also delta S n cap, right? Delta S is, right, delta S n cap, or this dot product means, you know this, E delta S cos theta. Dot product means E delta S cos theta. So here what is E? E is electric field delta S. What is delta S? Delta S is area, small area, and theta is, what is theta? Angle between this area element's direction and electric field's direction, right? That angle between E and delta S is what you call as theta here. Okay, this is about the electric flux. Just remember definition, equation. Okay, understood? Thank you.